Okay, so in this next experiment, I'm going to do the HiTech. So in the HiTech, we're using the software, the Pasco Probe software. And because this is a real lab, you're going to share your data with your partners at home. So partners at home, you're going to need to have SparkView open on your device. I do have the program. And if you want to install it on your computer, let me know and I'll send you the link. You can install it on your program and you can do it like that as well. All right? I'm just going to walk over here to the computer. Grab my mouse. Okay, so hopefully I can see everything well enough. So on the computer, on the Spark app, you're going to open it up, you're going to attach, you're going to connect to the pressure sensor. So this is the pressure sensor here. Right? So we haven't used this one before. I've already connected, as you can see. In terms of our collection, I care about the data. You can look at the graph because the graph will show you things. So you might want to look at both of them if that's helpful. Regardless of what you look at, you're going to be exporting the data to an Excel spreadsheet and using it from there. So I clicked on the graph. So in this graph, it will default. I'm using pressure. Okay, it's a pressure sensor. And instead of using this low-tech technique with water displacing, being displaced by gas, I'm just going to look at the amount of gas produced. And as more gas is produced, the pressure will go up. So it's going to be exactly the same experiment, but with this pressure probe. One of the things that you'll have to practice with this pressure probe is getting the end into the rubber stopper, because the holes aren't really that big. If you need help, and I can help you get this into the rubber stopper, but it's really tight. And it has to be tight, because if it isn't tight, you might get a leakage of air. And we don't want that. Okay, so I'm just putting this in here. I'm going to use my sweater so I don't hurt my fingers. So now I have my end of my pressure probe in this rubber stopper. I'm going to make sure that my rubber stopper fits in here, which it does. Okay, so same experiment, but now with HiTech. And with the HiTech, we'll be able to get great data. It'll be very quantitative. You'll be able to graph. You'll be able to get lines of best fit. You'll be able to do really good comparisons. Right? The reason why we did the low tech is because I wanted you to see what happens when you do this experiment. And if I just did the probe, many of you think, oh, it's like magic, I don't really know what's going on. But here you clearly saw that the gas was being displaced. The water is being displaced by the gas. There's gas being produced. In that tiny little bottle, we were able to produce probably 40 mils, if I let it run, 40 mils of oxygen gas from a tiny little bottle that holds probably 50 mils of whatever in the first place. So that's pretty remarkable. But once you understand that, we can go to the HiTech and then start getting some real data. So I'm going to do the same thing again. I've already separated my pieces here. I'm going to go to my graduated cylinder. I'm going to measure my 5 mils. Now when we do this experiment, typically I have a different concentration for the HiTech versus low tech. The HiTech, we want lots of bubbles. With the low tech, if you have too much pressure, it will cause the entire assembly to kind of blow up. And we don't want that. It'll be very frustrating. So I grab my discs, dip them in my enzyme. Remember, it's on ice. If it weren't on ice, then my enzyme would be decomposing as we speak, and you would be getting results that are going to differ based on the timing. And we don't want time of day, time of experiment to be a factor in this. We're trying to keep all the variables as even as possible. So I'm making this look pretty easy by taking this disc, putting in the enzyme, putting it on my bottle. Some of you might be a bit challenged to get it off your forceps and get it in. So you'll notice I'm holding it at the very tip, and that way when it touches the side of the glass, it will be more likely to touch the side of the glass. So I have my stuff sitting in here. At this point, I want to go relatively quickly. Because I'm by myself, I'm going to actually hit start now, and most of you are probably going to do this as well. So I'm going to hit start. So right now it's measuring the pressure at 98.2. I guess maybe I'll just remind you, maybe I'll stop it for a second here. So whenever you start and stop, you get a new run. And the run, if you want to see it, you check it or uncheck it. Reminder that you are sharing your session with each other. So you're going to click on the little 3 lines. You're going to click on shared session. The person at school, you're going to start a shared session. Give it a really easy name, right? So your name could be whoever you are. So clearly I'm Ellis. And then your session name, keep it simple. I suggest your group names, DSSS1, DSSS2. I'm going to call it DSSS. I'm going to be 23 because there's not 23 groups. Everything else here is fine. I click OK. And then if anybody joins me, I allow them to see. Okay, so that's just a reminder of how to do this. But once you have everyone joined, then hopefully that doesn't take too much time. You're going to click Start. Okay. So my other run is still there. I haven't lost it. Now I did a bad thing. I let this sit here for a while, but I was demonstrating something. So now I'm going to pour this in, my hydrogen peroxide that I measured out. If they're connected at home, they can tell you when to flip. So ideally you want to flip right when there is right when you're close to a 10 or a 5 or something like that. And so now I'm going to hold this in. Because if I don't hold it in, there's so much pressure being produced. You saw it, 40 mils of pressure, that this is going to pop off. It has to go somewhere. So as I hold this, for many of you, it'll be a challenge just to get to 2 minutes. And I will make it so that the concentration is less, so you're less likely to have those pops. When you're doing this, you're going to hold it tight. If you don't hold it tight, then it will pop off and you'll do the whole thing over again. I'm suggesting that you're trying to get 3 minutes of data, but honestly, because we're using probes, we can get even 2 minutes of data, maybe even less, and still have a good comparison. So right now I'm doing 4 disks, and you can see the chart. It's being created, right? It's going across. I can't actually read the times at the bottom, so I don't know when I'm going to hit that time. I don't have my stopwatch here beside me, but your partners online, they will tell you. And you want to make sure you don't shake the bottle, because if you shake it, I'll shake it now so you see what happens. If I shake it, see, look, that's an error. So you want to keep everything consistent. Once you flipped it over, you don't want to move it, you don't want to cough, you don't want to do anything. Just hold it steady. And then you'll get nice graphs, right? So I'll hold it for just a little bit longer. See that shake there? If I got that shake in the middle of my data, I'd do it over again, because that data doesn't allow you to get a good line of best fit, or else you have to shake all of them at that spot. It's just it's not a good scene. So make sure that you do everything you can to hold it here. So I'm going to actually take pressure off my hands, and you might hear the pop. So I'm pretending I'm holding it, but I'm kind of lost concentration. Oh, I lost concentration. And as soon as that happened, my experiment is over. If you get that pop, you're done. So you'll have to stop and redo if you don't have enough data. So I'll notice that when I did it here, I ran it for 120 seconds or so. So that's good. Like I said, I'm aiming for 3 minutes, but if you get 2 minutes of data, that's okay. So now I've done the 3 disks. I'm now going to go to, so I have 4 disks. I'm now going to go to 3 disks, and then 2 disks, and then 1 disk, and then with water. If your time is an issue, you might skip the water. So everybody's doing HiTech, 4 disks, 3 disks, 2 disks, 1 disk, 0. At the end of this, you're going to need to export the data. Because you're connected at home, you'll have the data, but you want to use Excel. This program here, it's kind of cheating in a sense, in that you're not creating the graph. I want you to create the graph. I want you to do the analysis. So in order to do that, there's a number of ways to send out this information. And I'm not sure you can do it when it's shared. So I'll probably make a different demo, and I'll show you how to export the data so that you can have it as an Excel document. Once you finish this HiTech, then each group's going to be assigned a small part. Some of you are going to be working with modifying the concentration of the peroxide. Right now it's 3%, that's what we buy it as, but you'll modify it down to 0.3% to 1.5% and see how the concentration of the peroxide enzyme affects the overall rate of reaction. Some of you will be working with metal salts, so I'll be giving you silver nitrate and copper 2 sulfate, 1 molar, 0.1 molar, and you'll see how that metal salt affects the enzyme rate. Some of you will be working with pH. You'll be changing the pH from pH of 7, which is neutral, down to pH of 2 and up to pH of 12 to see how the pH affects this enzyme. All right? I'm not giving you acids and bases. I'm giving you certain kinds of buffer solutions that will modify the environment pH. And in the fourth group, you will be working with temperature. You'll have hot plates and you'll have ice. You'll cool it down so that it's down to like 4 degrees, 10 degrees. You'll put it on a hot plate and get up to 30, 40, not too high because it would be too hot to handle, but you'll boil, maybe even boil the enzyme, and then that will look at the temperature effects, how temperature affected the enzyme. For those of you doing temperature, once you take out the temperature, you got to do it right away. If you do it too long, in the room temperature, temperatures at 70 will cool down to 40 really quickly. Temperatures at 4 will warm up to 20 very quickly, right? So that is the high tech I showed you a moment ago. Sorry, the low tech I showed you a moment ago, and the high tech I just showed you. You're doing both of those. I'll be watching to see how well you're able to work with the high tech. I might only have you do one run with 4 discs just to see what it looks like, and then get you to immediately move over to the high tech so that you can actually make it to the lab in 2.5 hours. All right? So everyone needs to come here prepared, ready to go. I'm hoping that all the Group 2 members, the Cohort B members, are here tomorrow, because that will be kind of difficult if your in-class person is not here.